To help you guys with evaluating functions, I wanted to just do a few problems from the book on here so you could see exactly how they're worked out. So this is where it is in the book. These are the problems I'm doing. And given in the directions are two functions. One is function f, and its equation is negative 2x minus 3. The other is function g of x, and its equation is x squared plus 5x. So on number 31, it asks us to evaluate the function f when x is equal to negative 1. So this means we need to plug negative 1 in for x. So what this is asking when it says f of negative 1 is to evaluate the function f when x is equal to negative 1. So I just write the equation, but I replace the x with a negative 1. Because they're wanting to know what is the y value when the x value is negative 1. Then we just follow the order of operations. Negative 2 times negative 1 is positive 2. 2 minus 3 is negative 1. So when x is equal to negative 1, the function, the y value, is also negative 1. Okay, 34. We're asked to evaluate f of 6. So this is asking us to find out what is the value of the function f when x is equal to 6. So again, I just rewrite the equation just as it is, but I replace the x with a 6. Because since x is equal to 6, I replace that x with a 6. Now I follow the order of operations. Negative 2 times 6 is negative 12. Negative 12 minus 3 is negative 15. Now in 35 they switch gears and they ask us about the function g. So 35 asks us to find what does function g equal when x is equal to 2. So if you look, we did have g of x. Now they've replaced the x with a 2, so they're saying find g of 2. So I plug 2 in for this x value. I plug 2 in for that x value. So if the variable shows up more than once, plug whatever's in the parenthesis in all those places. We follow the order of operations. 2 squared is 4. 5 times 2 is 10. 4 plus 10 is 14. Now 36 is also asking about g. It's saying what is the value of the function g when x is equal to negative 3. So I do the same thing I did on number 35, except instead of plugging in 2 for x, I plug in negative 3 for x. So x got squared, so now negative 3 gets squared. X got multiplied by 5, so now negative 3 gets multiplied by 5. Now I know there's some confusion from a few people about what you do when you square negative 3. Squaring something always turns it to a positive, because squaring means you multiply something by itself. So this is negative 3 times negative 3, and anytime the signs are the same, the result is positive. 5 times negative 3 is negative 15. And when you're adding numbers with different signs, this is a positive 9 and a negative 15. When you're adding numbers of different signs, you subtract the two numbers. So 15 minus 9 is 6. And you keep the sign of the bigger number, which 15 is bigger than 9, so we keep the negative sign from the 15. Okay, 37 does deal with g, but it adds one extra piece to the puzzle. It says find the value of the function g when x is equal to negative 2 and add 2 to that result. So this plus 2 out here has nothing to do with the function. Only this piece, g of negative 2, has to do with the function. So we're supposed to plug negative 2 into the function and then add 2 to that. So g of negative 2 would be negative 2 squared plus 5 times negative 2. Because the equation was x squared plus 5x. So we do negative 2 squared plus 5 times negative 2. So this is right here. G of negative 2 is these two terms. But we're told to also add 2 to that. So this plus 2 is not coming from G. It's just coming from the fact that they told us that after we plug negative 2 into the function, we should add 2 to the result. So we'll follow the order of operations. Negative 2 squared means negative 2 times negative 2, which is positive 4. 5 times negative 2 is negative 10. And we just keep the plus 2. So 4 plus negative 10. Again, we're adding different signs, one positive and one negative. So we subtract those two numbers. 10 minus 4 is 6. And we keep the sign of the bigger number, which is the 10, so it's a negative 6. And yet again, we're adding numbers with different signs, so we subtract them. 6 minus 2 is 4. And we keep the sign of the bigger number, which is the 6, so our final answer is negative 4. Okay, 38 does something similar, but with function f. It asks us to plug 0 in for x in the f function, and then subtract 7 from that result. So once again, I want to emphasize, this minus 7 has nothing to do with the function f. They're just telling us to plug 0 into function f, and then after that, subtract 7 from the result. So to get f of 0, I plug 0 in for x, so I get negative 2 times 0 minus 3. So that's f of 0. And then they tell us on top of that to subtract 7. Negative 2 times 0 is 0. 0 minus 3 is negative 3. And you might be able to do that in your head, and if so, that's great. But just to follow the rules fully, I'll do keep, change, change. And the addition rules say that when you're adding numbers with the same sign, just add them together, 3 plus 7, and keep the sign that they both have. So the answer would be negative 10. Okay, 39. They mix in some variables this time. They tell us to plug 4y in for x. So we're going to replace this x right here. This is the original function f. We're going to replace that x with 4y. Because whatever's in parentheses, you plug it in for x. So we get negative 2 times 4y minus 3. So I have negative 2 times 4, that's negative 8. And that's as far as we can go because these two are not like terms. This one has a y, this one does not. So we cannot combine those two terms. Our answer is right there. Okay, 40 tells us to plug a variable into g. So it says g of negative 6m. So again, whatever's inside these parentheses, we're going to replace the x's with that. So g of x was x squared plus 5x, but we're going to replace both of these x's with what's in the parentheses, which is negative 6m. So x got squared, so we also square negative 6m. X got multiplied by 5, so we multiply negative 6m by 5. Negative 6 squared is positive 36. M squared is m squared. 5 times negative 6 is negative 30, and we keep the m. And that's as far as we can go, because those are not like terms, because like terms have to have not only the same variable, but the same exponent. That has a squared, that doesn't. So that would be our final answer right there. Or another way it could be written is this way. That'd also be a fine way to answer. Both are equally good. Okay, last one. 41 tells us to plug c minus 5 into the function f. So we are going to take what's in this parentheses, c minus 5, and replace the x that's in f of x with that. So I do -2, and I replace the x with c minus 5, and subtract 3. So I have to use the distributive property. -2 times c, -2c, minus -2 times 5 is -10. And I can't combine the 2c and the 10 because they're not like terms. This has a c and this doesn't. But it's not really good to keep two negatives together like this. So you can think about keep, change, change. Just turn that to a +10. Because these two we can combine. They're like terms, they're constants. So we just say 10 minus 3 is 7.